How do we actually come up with the graph of a linear function? In order to draw the graph of a linear function, which we already know is a straight line, we just need to plot 2 points. We only need 2 points because 2 points fix a line in the plane. In general, to draw the graph, we like to have integer coordinates because those are going to, in general, be easier to plot. Of course, if we can't get integer coordinates, we can mess around with our axes, but integer coordinates are going to make our lives easier. And so we have a procedure for getting 2 points with integer coordinates that involve looking at the denominator of the slope and using facts about fractions. We'll get 1 point, and then we'll use the denominator of the slope to help us find another point. The facts about fractions we're using are, first, if we multiply a fraction by an integer multiple of its denominator, we'll get an integer. And in particular, if we multiply it by 0, we're going to get 0, which is an integer. And there are a lot of techniques for graphing linear functions. Graphing linear functions is something that we do all the time in algebra. And so there are a lot of techniques. A lot of them give us more insight than this one does into the structure of linear functions, and especially into the meaning of the slope. We're practicing this technique specifically because it's going to help us when we try to graph more complicated functions later. So here's how the technique goes. We have this example function here given in point-slope form. And the first thing we want to do is to be taking the slope times 0, because that's very easy arithmetic. And so we want to find x so that this thing that the slope is multiplied by is going to be 0. We want to find x so that x plus 1 is 0. Well, we'll just subtract 1 from both sides and get x is negative 1. And at that point, our f of x, that's going to be 5/3 times negative 1 plus 1, all plus 2, which, as we hoped, is going to be 5/3 times 0 plus 2. 0 plus 2 is just 2. So negative 1, 2 is going to be our first point with integer coordinates. Now, how do we find more points? Well, now we refer to this 3, and we change our x by 3. And we can go either way. We can add 3 to go to the right. We can subtract 3 to go to the left. Negative 1 minus 3 is negative 4. Negative 1 plus 3 is positive 2. If we plug these in, well, when x is negative 4, we have 5/3 negative 4 plus 1 plus 2. That's 5/3 times negative 3 plus 2. 5/3 times negative 3 is negative 5. Negative 5 plus 2 is negative 3. So we have a point at negative 4, negative 3. That's way down here. When x is 2, we have 5/3 times 2 plus 1 plus 2. That's 5/3 times 3 plus 2. 5/3 times 3 is 5. So 5 plus 2 is 7. We have another point at 2, 7, which is way up here. And we notice when we draw the straight line that goes through this point and this point, well, that straight line automatically goes through this point down here as well. So we can confirm that if I draw the straight line through two of those points, it's going to go through the third one as well.